All right, so you missed lesson 6.3.4. It's all about pH. Let's take a look at this data here. It says that we've got these different pHs that go with these different concentrations here. So what do we think pH really represents? Well, we've talked a little bit about it in class. It represents something to do with the concentration of hydrogen ions versus the concentration of hydroxide ions. And you may have been able to figure it out by looking at this if you've got a math brain. But if you take the negative log of the hydrogen ion concentration, that's actually equal to the pH. So in other words, 10 to the minus pH is equal to the hydrogen ion concentration. So for example, in this first one here, 1 times 10 to the negative 1 is the same as 0.1. And if you look at this, pH here would be equal to 1, which it is in the chart. Versus this next one, 1 times 10 to the negative 2, that's a smaller concentration of hydrogen ions. That's the same as 0.01. The pH here would be 2. So the greater the hydrogen ion concentration, the lower the pH. And by the way, when you see those brackets around like an H+, it means concentration, which it goes into a little more detail there. Okay, so let's see if we can figure out what these missing spots are in this graph by looking at the trends, and we've already seen it a little bit. So pH is equal to the exponent when the hydrogen ion concentration is written in scientific notation. It's also equal to the number of zeros that are present in the decimal form. So plus 1, I should say. So we'll kind of look at some of the examples of that together. So for this one, the stomach acid, it must have a pH of 1 because this is 1 times 10 to the negative 1. And the clear soda, since it has a pH of 3, we know that that's an acid and that this concentration must be 1 times 10 to the minus 3. Next one has 1 times 10 to the minus 6th, a smaller concentration of hydrogen ions, so that must have a greater pH closer to 7. And here we can do 1, 2, 3, 4, 5 zeros and a 1 because that's the same as 1 times 10 to the negative 6th. The next one, distilled water, 1 times 10 to the negative 7th. That's neutral. And alcohol is the exact same. So there should be 6 zeros there. 1 times 10 to the minus 7th. And the next one is the exact same here. Salt water, also a pH of 7, neutral. 1 times 10 to the negative 7th. Now we're getting into some basic solutions. This is going to be a really small concentration compared to some of the others. 7 zeros. The next one is 1 times 10 to the negative 10th. So that's for ammonia, pH of 10, basic. This one's got a pH of 13, definitely basic. So this is going to have 12 zeros. 1 times 10 to the minus 13th. And when the concentration of hydrogen ions is really small here, it's going to be a pH of 14. 13 zeros. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can see some of the trends here. Let's look at the questions. If you know the concentration of the hydrogen ion solution in decimal form, how can you figure out its pH? It's the number of zeros after the decimal plus 1. If you know the concentration of a solution in scientific notation, explain how you can determine its pH. Well, it's just equal to the negative exponent. So for example, in this one here, 10 to the minus 14, the minus 14 is equal to the pH. As pH goes up, the concentration of the hydrogen ions is going down. You'll notice this number over here is getting smaller and smaller as the pH in this column is going up and up. As the pH goes down, then the hydrogen ion concentration must be going up. What if you've got two solutions? One has a pH of 5, one has a pH of 9. The concentration of the hydrogen ions would be 0.00001 and 0.000000001. In other words, that's the same as saying 1 times 10 to the minus 5th and 1 times 10 to the minus 9th. Since solution A has a pH less than 7, that would be an acid. And since solution B has a pH greater than 7, that would be a base. And the larger number is, of course, solution A. That is a bigger number than this concentration here. How many times bigger? If I take 0.00001 divided by 0.000000001, that is 10,000 times larger. Oops, there we go. And kind of a cheat way to do that, these are all, every time pH goes up by 1, it's changing by a power of 10. So from 5 to 9, that's a difference of 4. So you can do 4 zeros after the 1 to know what how much greater the concentration is. So there are 10,000 times more hydrogen ions in a solution that has a pH of 5 than a solution with a pH of 9. Let's take a look at pH versus pOH. So basically they're opposites, and you can see that pH plus pOH is always equal to 14. So we can easily go in and write in these other missing numbers here. 5 plus 9 is 14, 6 plus 8, 7 plus 7, 7 plus 7, 8 plus 6, 10 plus 4, 12 plus 2. So just like pH is related to the hydrogen ion concentration, pOH is related to the hydroxide ion concentration. So we can follow the patterns. This will be 1 times 10 to the minus 13, 1 times 10 to the minus 11, 1 times 10 to the minus 9th, 1 times 10 to the minus 8th, 1 times 10 to the minus 7th, and I'm not sure why they have so many different examples of the neutral. 1 times 10 to the minus 7th, 1 times 10 to the minus 7th, 1 times 10 to the minus 6th, 1 times 10 to the minus 4th, and 1 times 10 to the minus 3rd. Okay, let's look at some questions. What does brackets around OH minus stand for? It stands for the concentration of hydroxide ions. What can be said about the concentration of hydroxide in solutions with a high acidity? It's going to be very low, because if it were high, it would be a base. So we can see if the acidity is very high, meaning a low pH, look at how small this number is for the concentration of the hydroxide ions. Hopefully I got the right number of zeros there. Very small. What can be said, or how is the value of pH related to pOH? We talked about this. pH plus pOH is 14. So if you know the value of the pH, you can determine the value for pOH by subtracting the pH from the 14, and then you'll know your pOH. If you know the value of the pOH, how can you figure out the value of pH? Very similarly, just subtract from 14. And this is kind of a repeat question to number 8. They're related to each other mathematically because they add to 14. And H plus and OH minus, if you multiply them together, they'll multiply to equal 1. Times 10 to the minus 14. What about figuring out the pH of a solution with a hydroxide concentration of 1 times 10 to the minus 12? Well, that would have a pOH of 12, so that means the pH would be 2. And then it is on to the homework. So that should give you a pretty good start.